All right, in chapter 6.1, we're going to talk about algebraic expressions and formulas. So just make this the title of your notes, chapter 6.1, algebraic expressions and formulas. On this first example, it says to evaluate 7x plus 5 for x equals 10. And if you'll notice up here, it says evaluate just means for us to plug it in and work it out. So all you're going to do is in the place of x, you're going to put 10 in the place of x, and then you're going to work it out. So we have 7 times 10 plus 5. 7 times 10 is 70, plus 5 is 75. All right, for example 2, we're doing the same thing, but here we have a little bit longer expression. Again, you're just going to plug, in this case, we're going to plug -6 in the place of x, and we're going to work it out. So I'm plugging in a -6. Notice I'm putting that in parentheses because the -6 is what x is equivalent to. So -6 in parentheses squared plus 5 times -6 minus 3. And then just work this out like you normally would do in your order of operations. -6 squared is positive 36. Positive 5 times -6 is -30. Minus 3, and just work left to right doing your subtraction. 36 minus 30 is 6. 6 minus 3 is 3. Again, here in example 3, all we're going to do is plug in, work out, but here you have two different variables that you're plugging in the place for. So I'm going to do -2 times, in the place of x, I'm going to plug 4. So -2 times 4 squared plus 5 times, in the place of x, I'm putting 4, times, in the place of y, I'm going to put 2 minus 2 squared. And then, again, follow your order of operations. You have -2 times 4 squared is 16, plus 5 times 4 is 20, 20 times 2 is 40, minus 2 squared is 4. And then again, just next line, do order of operations. -2 times 16 is -32, plus 40 minus 4. And then work left to right. -32 plus 40 is 8. 8 minus 4 is 4. In example 4, we're going to be talking about the distributive property. And remember, the distributive property is just you're multiplying stuff on the outside of the parentheses times everything on the inside. So in this example right here, you've got a times b is ab, and then plus a times c is ac. And over here you have numbers that shows you an example. Notice 5 times 3x is 15x, and then you've got plus 5 times 7 is 35. So remember, distributive property, you're just multiplying everything on the outside times stuff on the inside of the parentheses. So example 4, we're applying the distributive property. It says the optimum heart rate is the rate that a person should achieve during exercise for the exercise to be most beneficial. The algebraic expression 6/10 times 220 minus a describes a person's optimum heart rate in beats per minute, where a represents the age of the person in years. A part says use the distributive property to rewrite the algebraic expression without parentheses. So for A part, we're just going to take 6/10 times 220 minus a, and we're just going to distribute here. So 0.6 times 220, and you're just going to put that in your calculator, and you're going to get 132. And then distribute 6 times 0.6 times -a is -0.6a. That's all you're doing in A part. B part says use each form of the algebraic expression to determine the optimum heart rate for a 20-year-old runner. So what you're going to do here, I want a 20-year-old runner. And remember up here it says where A represents the age of the person in years. So we want to do, it says to use both forms, each of those forms. So we have 0.6 times 220 minus, and in the place of A, we're going to put 20. And in the other case, we're going to do 132 because it says use both forms. 132 minus 0.6 times 20. and you'll see that you get the same thing. So right here, order of operations, you're going to do 0.6, and then in here you have 220 minus 20 is 200, and then 0.6 times 200 is 120. And then when you do it this other way, you have 132 minus, and then 0.6 times 20 is 12, and then 132 minus 12 is 120. So you get the same answer either way that you go. On example 5, we are combining like terms, and if you'll see here, like terms means that your expression, for you to put like terms together, you have to have the same variable with the same exponent on the variable. So you got to have the same variable and same exponent with that variable for them to be like terms. So A part here, we have 12y plus 9y, and they both have y's in them, so just add the coefficients, which I mean the number in front of the variable. Add the coefficients, leave the variable alone. So 12y plus 9y is 21y, and that's all you can do for that problem. B part, you have 8x minus 10x. They both have both terms have x's, and remember terms are separated by plus and minus signs. So I have two terms here. 8x minus 10x is negative 2x. 8 minus 10, those signs are different, so you subtract and take the sign of the larger number. C part, you have x plus 7x. Well, remember, if there's not a number in front of that variable, it's an understood 1, so that's really 1x plus 7x. And 1x plus 7x is 8x. No big deal. You're just combining like terms. And then D part, we have 3x squared minus 7x squared. And if you'll notice, this x squared and this x squared are the same thing, so these are like terms. So again, just do what your coefficients say to do, and that says 3 minus 7. So 3x squared minus 7x squared is negative 4x squared. And that's all there is to combining like terms. Example 6 gets just a little more complicated. You've got more than one variable here, or you have more than one set of like terms. So again, just combine your like terms. And what I do, I like to underline or square off or circle my like terms, including the sign in front of that term. So here I have a positive 7x and a positive 3x that go together. So that says 7x plus 3x is 10x. And then I have a positive 5 and a positive 8. Those terms go together, so that's positive 5 plus 8 is positive 13. So this answer is 10x plus 13. On B part, again, I'm going to underline or circle or square off my like terms. So I have a positive 4x and a negative 2x that go together, and that's 4x minus 2x is positive 2x. And then I have a positive 7y and a negative 9y. 7y minus 9y is negative 2y. And then I have just constants, no variables. So I have a positive 11 and a negative 3. So 11 minus 3 is positive 8, and I've got to put that plus sign there. So I have 2x minus 2y plus 8. Number 7 contains parentheses. Here we have to distribute first and then combine our like terms. So I'm going to distribute. 5 times 3x is 15x. 5 times negative 7 is negative 35. And then I'm just going to bring down that minus 6x. And then I'm going to combine my like terms. I have a positive 15x minus 6x is positive 9x, and then I have nothing to combine with that minus 35, so I'm just going to bring it down. So 9x minus 35. Example 8, again, I have to get rid of my parentheses here. And if you'll notice, there's not a number in front of that parentheses, so that's an understood 2x minus 1 times 3x minus 4y plus 6. So I'm rewriting that to where I have a 1 in front of that parenthesis, so I know that means I have to distribute a negative 1. So I'm just going to bring that 2x down, and then I'm going to multiply negative 1 times positive 3x is negative 3x. Negative 1 times negative 4y is positive 4y. Negative 1 times positive 6 is negative 6. And then I'm going to combine my like terms. I have a positive 2x minus 3x is negative 1x. And then I've got a positive 4y. I don't have any more y's to go with that, so I'm just going to bring down plus 4y. And then I've got a minus 6 and no other terms to go with it, so I'm just going to bring it down. So this final answer is negative 1x plus 4y minus 6. All right, our final example, example 9, we're modeling. We have a word problem here using formulas and evaluating. It says the formula P equals 0.72x squared plus 9.4x plus 783 models the gray wolf population in the United States P. So this P stands for the population of the wolves X years after 1960. So that X represents the number of years after 1960. It says use the formula to find the population in 1990. Well, if I'm looking for the population in 1990, 1990 is 30 years after 1960. So 30 is what's going to be X. So how well does the formula model the actual data shown in the bar graph in figure 6.1? So what we're going to do here, it says use the formula to find the population in 1990. So I'm going to just write down the formula. P equals 0.72, and in the place of X, I'm putting the number 30. So 0.72 times 30 squared plus 9.4 times 30 plus 783. And then I'm just going to work this out. So the population is 0.72 times 30 squared. You're going to have to get your calculator. So 30 squared is 900 plus 9.4 times 30. And here you could have gone ahead and put that in your calculator as well, but I know I've got to show some work in the next step, so I'll just do it all. So 0.72 times 900 is 648 plus 9.4 times 30 is 282 plus 783. And then just put this all in your calculator. 648 plus 282 plus 783 is 1,713. So the population of the gray wolves in the United States in 1990 is 1,713. And if we'll look, the population, if we'll look at the chart in 1990, the population is 1,700. That's the estimated population there, and 1,713 is pretty close.